All right, this is question number 3. Calcium carbide reacts with water to produce acetylene. Calculate the mass of this required to make 53 grams. So we start with 3 sig digs right there of, 4. There's 2 zeros there, of C2H2. You can see that right there. So we'll end with 4 sig digs. That's my point. And then step number 1 for these types of problems, remember, is to have the balanced chemical equation. That's given to us right here. Step number 2, when in doubt, convert to moles. So we're going to convert these grams to moles. So grams right here, moles is your new set of units of C2H2. Once we convert to moles, then we'll go to step number 3 and we'll use the ratio from the balanced chemical equation. And it asks for the mass of calcium carbide that is required. So we're looking from here to here, right here, and you can see that C2H2 has a 1 in front of it, and CaC2 has a 1 in front of it. So for every C2H2, 1 mole of CaC2 is needed to make that. And then it wants the mass, so then step 4, whatever units they want you to convert to, that's what you have to do at the end. So we're going to go to grams of CaC2 here at the end from moles of CaC2. So first we've got to add this up on the periodic table, so that's why I've got this here. Carbon, of course, is 12. 12 times 2 is 24, plus 2 more is 26, so 26 grams in mole. And then up here, calcium is 40, and then add 40 plus 2 carbons, so that's 24. So we've got 64 grams in a mole right there. So following through all those steps on a calculator now, let's see if I can have this live on here. There we go. 53 divided by 26, enter, times 1 divided by 1. And then times 64 right here, that'll give us our mass. So our mass should be 130.5 or more, round up right here, so 0.5 to 3 sig digs, and it'd be grams of CaC2. That's part A. Part B says the 53 grams of acetylene, this created in reaction A, is collected at 50 degrees Celsius in a 0.1 liter container. Calculate the pressure exerted by the gas, and they give us this really nice little equation right down here, and they give us an R even, and they want the pressure in atmospheres, so they give us the R in atmospheres right here. So organize your data first. We have the mass is 53 grams. We have the temperature at 50 degrees Celsius plus 273, because remember we're going to be in Kelvin. And then the volume is a 0.1 liter container. And then we know the molar mass because we added up acetylene gas right here on the periodic table, and that's 26 grams per mole. And now we can take this equation and we can solve it for pressure. So we have PV equals mass over molar mass times RT. Divide both sides by V right here to get the pressure. So now we have pressure equals MRT divided by molar mass volume. So now we can put everything in here. So 53 grams times 0.08206 liters times atmospheres per mole times Kelvin. Get that from right here. And then our temperature right here would be 50 plus 273, so 323 Kelvin. And then divide that by the molar mass, which is 26 grams per mole, so my grams will cancel with my grams. And then my volume right here is 0.1 liters. Make sure that's in liters because you need your liters to cancel with your liters right here. Notice my kelvins cancel with my kelvins, and my moles go with my moles right here, so I'm left with atmospheres as my units. Let's see if we can do this all at once on the calculator, or at least in a couple steps. 53 times 0.08206, enter, times 323, enter, divided by 26, enter, and then divided by 0.1, enter, and I get a pressure of 540 ATM. Ooh, big time pressure. There we go. That's number 3.